Okay, so let's solve this problem. You're in a car and you're looking up at a building that's 15 meters high. So first let's draw the horizontal or the ground. So I'm going to draw a straight line across. You're looking up at a building that's 15 meters tall. So draw a straight line up, and the position of the car is going to be, let's label it A. Let's say that your car is over here. An angle of elevation is always drawn from the horizontal looking up, as if you're looking up from the ground. So let's draw this angle of elevation here, and I'm going to label it 15 degrees. There. The height of the building you're looking up at is 15 meters. So that's that part there, and you're always going to assume this is a 90-degree angle. So what happens is this car moves forward. It moves closer to the building. So it's going in this direction. It's going to move some distance away. We don't know how close it goes, but let's just say, let's arbitrarily put that point there. Say it stops, and I'll label that point B. We're going to draw a second angle of elevation. So you're looking up at the building again, like that. This time your angle of elevation changes to 25 degrees. So you're going to put 25 there. The question becomes, what is the distance it moves? So what is the distance from A to B? I'll write that down here. What is the distance from A to B? Well, how are we going to figure this out? Look at your diagram carefully. If we could figure out the distance from A all the way to the edge of the building, let's call that distance x. If we could figure out x, and we could also figure out the distance between B and the building, then we could subtract those two values and very easily get our answer, because that's going to be the difference between A and B. So why don't we start by finding x, or the distance from A to the building. From A, look carefully from 15 degrees. We have the opposite side, which is 15 meters, and we're looking for the adjacent side. Opposite and adjacent, that means we're going to use tan. So the tan of 15 degrees is going to equal opposite over adjacent. We need to solve for x. X is going to equal 15 divided by the tan of 15. And when you do that in your calculator, x should equal about 55.98 meters. All right, so now we have distance x. What I'm looking for now is the distance from B to the edge of the building. So again, let's use a variable to represent that distance. I'm going to call it y, just to be simple. So again, from an angle of 25 degrees, we're still going to use tan because the opposite side is 15 and the adjacent side is what we need. It's called side y. So I'm just going to go to a fresh slide here, and I'm going to write out that ratio. The tan of 25 degrees is going to be the opposite side over the adjacent side. And again, we need to solve for y. So y is going to be 15 divided by the tan of 25. When you do that in your calculator, y should equal about 32.17 meters. All right. So again, if you look at your diagram that you've drawn on your page, we want the difference between those two values. So I'm just going to draw a line here. And one last step is to do a subtraction. So we need to do x minus y, which is going to give us the distance AB. That's what the question was asking. So let's do that quickly. 55.98 minus 32.17, and AB is going to equal 23.9 8.81 meters. And that's your solution. So there's only 2 examples for this lesson. I'm going to post a couple of questions you can try on your own, and email me if you have any trouble with this. Remember your ratios, SOHCAHTOA. If you're looking for a side, make sure you're using the right ratio. Ask yourself, what sides are being given? What angle am I looking at? And more importantly, what am I looking for? Are you looking for a side? Are you looking for an angle? Make sure your diagrams are clear. If you want to watch this again from the beginning, I'd suggest it. Make sure your diagrams are clear, and I'll post a couple of examples you can try on your own.